In computing, network topologies refer to the arrangement or structure of how devices, known as nodes, are connected within a network. These configurations dictate the flow of data and the efficiency of communication between devices. There are several distinct network topologies, each with its own characteristics, advantages, and drawbacks. Among the most common are the star network, the bus network, the ring network, and the mesh network. A star network is one of the most widely used topologies. In this configuration, all devices are connected to a central hub or switch. The hub acts as a mediator, facilitating communication by receiving and distributing data between devices. The primary advantage of a star network is its simplicity and reliability. If one device fails, it does not affect the rest of the network, as each device operates independently. However, the central hub is a single point of failure, meaning that if it becomes faulty, the entire network is disrupted. Star networks are commonly found in offices, homes, and schools as they are relatively easy to install and troubleshoot. The bus network, in contrast, uses a single central cable, known as a backbone, to which all devices are connected. Data is transmitted along this shared cable, and each device listens for data addressed specifically to it. The bus network is cost-effective and easy to expand, as additional devices can be connected directly to the backbone. However, it has several limitations. If the central cable fails, the entire network goes down. Additionally, as more devices are added, data collisions can occur, reducing the efficiency and speed of the network. This topology is less common in modern networks due to these drawbacks, but was historically popular in smaller or less demanding environments. A ring network is a topology in which each device is connected to exactly two other devices, forming a circular pathway. Data travels in one direction around the ring until it reaches its intended destination. The main advantage of this configuration is its predictable performance, as the flow of data is controlled and collisions are avoided. However, the ring network has a critical weakness. If any single device or connection in the loop fails, the entire network is disrupted unless a dual ring setup is used. Ring networks are less commonly implemented today, but have been used in certain specialized applications where predictable data flow is important. The mesh network is perhaps the most robust and flexible of the topologies. In a mesh network, every device is connected to multiple other devices, creating numerous pathways for data to travel. This redundancy ensures that if one connection fails, data can still be transmitted via alternative routes, making the network highly reliable. Mesh networks can be categorized into two types: full mesh, where every device is connected to every other device, and partial mesh, where only some devices have multiple connections. While mesh networks provide excellent fault tolerance and performance, they are costly and complex to set up, as the number of connections required increases significantly with each additional device. This topology is often used in critical applications, such as military communications or large-scale wireless systems, where reliability is paramount. Each of these topologies, star, bus, ring, and mesh, has its own unique characteristics suited to specific scenarios. The choice of topology depends on factors such as the size of the network, the required performance, cost considerations, and the importance of reliability. Understanding these different configurations helps in designing networks that meet the specific needs of their users and environments.